Hello, everyone. This is Pat Masi-Phelps. I am a partner sales engineer at Dataiku. And today I'm going to talk to you about cloud-optimized AI solutions with Dataiku and Snowflake. Thank you so much for taking the time to listen to this presentation. Okay, so a quick note on the Dataiku and Snowflake partnership. Dataiku was named Snowflake's Data Science and Machine Learning Partner of the Year the past 2 years in a row, 2021 and 2022. And the reason for this is that these two technologies combined make up the best-in-breed solution for data science, for organizations to start making more data-driven decisions, for organizations that want to develop more AI applications, all while democratizing all of these things to their entire workforce and adding governance and centralization and process to all of it. Dataiku's gotten a number of competencies and certifications from Snowflake, all of these things right here, including a few industry competencies across healthcare and life science, financial services and retail and CPG. So this is a diagram showing Snowflake and Dataiku integrations in an architecture diagram. So Dataiku handles the entire data science and analytics lifecycle, everything from bringing data in to data preparation and feature engineering, machine learning, model training, and creating data products like models ready for real-time scoring, ready for batch scoring, dashboards, approved data sets like a feature store, all while making sure that data is secure. There are governance processes around each of these projects. Your models are managed and monitored properly. This is all overlaying everything about Dataiku projects. And so the way that Dataiku does stuff is by connecting to data sets somewhere using things that we call recipes, which are like transformations to get from one data set to another. And Dataiku has a number of visual recipes, also code-based recipes, so that business analysts, coders, data engineers can all work collaboratively on projects together. And so there are a lot of different integration points between Dataiku and Snowflake. Dataiku can read in Snowflake tables using the generic JDBC connector. We can do fastpath syncs from cloud storage into Snowflake. We can use Snowflake streaming APIs. We can also connect to Snowflake marketplace data. So a lot of stuff in terms of reading data in and writing it out. Now, in terms of these Dataiku recipes, these data transformations, Dataiku can push the compute of these visual recipes down to Snowflake. So you can really leverage the power of your Snowflake warehouses to run things like joins, run things like data cleaning operations. You can even push Python code down to Snowflake as your engine using Snowflake Snowpark APIs. And again, all of this is accessed through the Dataiku UI, through your Dataiku projects, but using Snowflake tables and Snowflake compute behind the scenes. So Dataiku can also connect to other types of data storage options. Every organization has their data stored in a million different places. Dataiku also has some visual machine learning training capabilities. So if you want to train your models with just a few clicks, you can do that. And you can even push down batch scoring jobs as Snowflake UDFs down to Snowflake for batch scoring. That's another nice integration that I like between these two tools, Dataiku and Snowflake. But obviously there's a lot of complexity to this diagram, and I won't go through everything, but those are a few highlights that I wanted to point out. Just bringing in data from all these different places. We love when our data is stored in Snowflake. Dataiku can push down the compute of all of these visual recipes and Python through the Snowpark APIs, and also a nice little note on pushing down machine learning inference as Snowflake UDFs. Okay, so now I want to talk about a cool case study that I worked on with Snowflake. So Dataiku has been a data science platform of choice for an international pharmaceutical firm for about 5 years. And an SVP at this company had this quote they said, Dataiku is both the lubricant and the glue. It makes things go faster while holding them together. And this is in the context of their analytics organization, which we think is a nice way of saying, bring everyone together, but also let's let them do their thing and do their jobs quicker. And recently we worked with Snowflake at this pharmaceutical company to speed up their workloads, which were previously running Spark on EKS, which is Amazon's Elastic Kubernetes service, with S3 as the underlying data storage option. And so all of these were previously Dataiku workloads running on Kubernetes using Spark. And we transitioned a few workloads over to Snowflake to do data storage and run the compute. And we found that, for example, one data processing job, which previously took 10 minutes running on Spark on S3 on Kubernetes, then took just 15 seconds to run in Dataiku using Snowflake. And so this was, for example, like pushing Spark SQL code to just SQL running on Snowflake, pushing PySpark code over to Python and Snowpark on Snowflake, as well as some visual recipes. This is a nice little example for a pharmaceutical firm. So this got us thinking, hey, we should probably do some internal testing on this. So we took an example, super simple workload, where our data was stored on S3. We were doing a few different types of recipes, so a few different visual transformations. We took a couple PySpark scripts and a couple visual recipes in Dataiku. This was like a data cleaning operation, kind of some if-then statements. And this is a group by aggregation. And all of this was running using Spark as the engine. It was running on a Kubernetes cluster hosted by Amazon, so EKS. And we decided to move our data over to Snowflake and change each of our recipes from PySpark over to Snowpark, so using the Snowpark APIs. And then we pushed our visual recipe compute down to Snowflake's SQL warehouse engine. And the visual stuff happens automatically behind the scenes, right? Dataiku does all of that magic for you. But we did have to rewrite the PySpark code as Snowpark, which was a relatively easy lift. And what we found from transitioning this workload was that when we ran each of these 4 recipes on 500 megabytes of data, 5 gigs, about 50 gigs, and 500 gigs of data, what previously took us 5 hours and 28 minutes to run on Spark on EKS on S3 using Dataiku and cost about $60 was reduced down to 2 hours, 22 minutes on Snowflake at less than half the cost, at $30. Here's a table just kind of like going row by row. So specific Dataiku recipe, how big was the data, and then what was the amount of time it took for this to run. So for example, a visual group by 500 million records, 5 gigs, took Snowflake 3 seconds to run versus Spark on EKS plus S3 about 1 minute and 9 seconds to run. So kind of interesting here. And note over here on the right, Spark configurations that we had to do for our Spark on EKS jobs. Right, and so these we changed a little bit for different jobs. And I think this is an important advantage of running your big data workloads on Snowflake, is that when we ran our Dataiku workloads on Spark using EKS on S3, we had to tune these Spark configurations to really reach an optimal speed and cost performance. And this required some pretty senior engineers who had been using Spark for maybe multiple years at this point. And it spent these like really valuable resources some time to test out these different configurations. And Spark tuning, while you can come up with some smart stuff from the get-go, does require a little bit of guess and check. But the nice thing about moving to Snowflake was that we didn't have to tune any of these Spark configurations, like executor memories or executor cores or our Kubernetes memory overhead factor, right? All we had to do was just use the same medium warehouse for all of these jobs, which meant that, if you're running your stuff on Snowflake, this means that big data processing is more accessible to everyone. You don't need necessarily senior engineers to be able to do this stuff. But if you do want your senior engineers to be working on this stuff, it means that they can develop products quicker. I thought that was a really nice example of some internal testing we did at Dataiku. Again, comparing some Dataiku workloads running on Spark on Kubernetes, which we moved over to Snowflake and really saw some nice performance and cost gains. Okay, cool. So next I'm going to give you all a demo of Dataiku. Okay, so Dataiku is a web-based application. I'm accessing my instance just in my Chrome browser here. And as I'm looking in my instance here, each of these boxes is a different project, which aims to do something different. So companies will have like different projects, different project folders for their different teams typically. And if I take a look at this credit scoring project, I immediately see a flow. And this flow is a visual representation of this project. The blue squares are data sets, and the circles are something that we call recipes, as I mentioned earlier. And a recipe is just a transformation to get from one data set to another. So in this case, it's two data sets go into the join recipe, one data set comes out. And if I click on any data set, I can see all the different options of recipes over here. So you can see Dataiku is a bunch of like point and click recipes, which lets you filter data, clean it up, do group by aggregations, join it together. But also in the same workflow, you can have your programmers coding in Python, coding in R, coding in SQL, all in the same workflow. So this really is meant to be a collaborative environment where your business users can collaborate with your data engineers and data scientists. Cool. So in terms of Snowflake stuff, you all can probably see some things right at the beginning where we're using Snowflake. So in this workflow, we're using Snowflake to store our data every step along the way. Each of these blue boxes is a Snowflake table, except for this one, which we'll talk about, which is on S3. But you can bring in data from your Snowflake instance. In this case, we're just connecting to a table of unemployment data, reading in from a particular database and a particular schema, right, in the Snowflake database. You can also write Python code to, for example, write a custom query to query from your Snowflake database if you want. In this case, we're actually using a Snowpark session to get this table and then write it out somewhere. Cool. So we're bringing in data from Snowflake. In this case, our project aims to take in data from like past loan applications. So let's pretend that we're a consumer bank and people want loans for various things, like to buy a car or buy a house or refinance credit card debt, stuff like that. And so we have all this data, let's say on past loan applicants. So we have information like how much money do they want from the loan? What's their what kind of job do they have? Are they a pharmacist? Are they a superintendent? What's their annual income? What's the purpose of this loan? So is it like credit card, debt consolidation, etc.? What state do they live in? All these things you might expect a bank to request in like an input form. And let's say as a first step of our process, we want to maybe join our loan data with like unemployment data about the larger market. And so here we use a visual join recipe in Dataiku to join these two tables together. And in this case, we're doing a left join, where our loan data set is our left data set. And we're joining on a shared column between these two data sets, which happens to be loan ID in this case. We can always click into this field and change the columns that we want to join on. Or you could potentially join on multiple columns being equal to each other. right? And then in this tab, I can say, oh, I want to exclude this column from my output data set. And to actually go ahead and build our output data set, all I need to do is click this run button. And Dataiku will go ahead and generate a query for you automatically. So this will create a SQL query. Here you can see a left join on this loan ID column being equal, right? And so Dataiku will orchestrate pushing this SQL query down to your Snowflake instance. So if I look at my activity on my Snowflake instance now, I'm just sorting by like when this thing happened. I can see this is the query that I just ran, right? So here I can see left join on loan ID equals loan ID. Right, so here your data is never moving out of Snowflake. The inputs are stored in Snowflake. Dataiku is automatically generating that SQL query, pushing it down to Snowflake to run the compute on your warehouse, and writing the output data set also to Snowflake. So here Dataiku is just caching a sample 10,000 records into memory, but it's really just pointing at that underlying Snowflake table. And let's say you wanted to do, I don't know, like a chart. Maybe I wanted to look at something like my states of my loan applicants and just a pure count of records for each state. Right here, my engine is in database. So again, if I look at my query history, this guy right here, this select count star from our join data set, which is this one right here, grouped by a couple just like variables that we got, which is actually just grouped by address state, right? So Dataiku will generate all these queries for you automatically, which just means super fast charting behind the scenes and creating these things, even if you're dealing with like millions of records or billions of records. Right, so everything from like running these recipes in your pipeline to just analyzing your data, analyzing your columns, you're able to leverage the power and investment that you've made in Snowflake. Okay, so something that I think is pretty cool, Snowflake recently released the Snowpark APIs for Python, which means that if you are a Python coder, you can, in the same workflow, write Python code and push the compute of, say, writing case when statements or filters using the Snowpark APIs, right? So this is just a bunch of Python code. We're importing the Snowpark APIs. We're able to connect to our input table. And then, yeah, we're using the Snowpark APIs to do all sorts of interesting data science work. Here, it looks like we're doing a, grouping. We're doing like a mean calculation or a standard deviation calculation, even normalizing a particular column, all using Snowpark to really speed up this computation. Right, and so here in the like data science process and the data science journey, right, we've like joined our data together. Maybe we've done a little bit of Snowpark writing to do some interesting feature engineering. Now maybe we want to split our data into maybe some training records versus like loan applicants that we don't know if they're going to pay back their loan yet or not. So let's go ahead and train a machine learning model, which will like pick up on underlying patterns of loan applicants' features and whether or not they pay back their loan to try and predict whether like future applicants will pay back their loan or not. And so in Dataiku, all it takes to train a model is just a few clicks. You can go to our lab and then auto ML prediction. And you say, like, what do I want to predict? So you can predict loan status, and let's do some quick prototypes. Right, and so I can see here that this is a 2-class classification problem. 5% of my loan applicants historically had an incident, and then 95% were okay. So clearly an imbalanced problem, but nothing a data scientist can't fix. And you data scientists should recognize a lot of these concepts. You can tune the train-test ratio of your training process. You can optimize your model for different metrics like AUC. You can add in things like dataset sanity checks or leakage detection stuff. Just make sure that you're not like training a model that goes awry. In the features handling tab, I can say, okay, I want to include employment length, how long people have been employed for in years as a feature. Do I want to do any rescaling to that feature? In the algorithms tab, you can choose to turn on and off different machine learning algorithms to test out. So here we're going to try out random forest, logistic regression. Maybe you want to check out light GBM too. And when I hit train, Dataiku is going to do like a bake-off behind the scenes. It's going to train all these different models based on our known data of loan applicants, and it's going to see which one performs best. And so continuing the bake-off analogy, I'm going to go to an already trained model and show you guys what it looked like. So if we go to this previous session, we can see looking at the metric RUC-AUC, where a 1.0 is a perfect model, right? But we live in the real world and nothing is perfect. So the best performing model of this session was our light GBM model with a 0.90, which is pretty good. If I look at this model, I can look at things like a confusion matrix. So of our 1,400 like okay loan applicants, our model correctly predicted that many of them were indeed going to be okay. Of our loan applicants which had incidents, our model correctly flagged 44 out of 72, but it missed 28. Right, and so you can even like tune your model's threshold. Cool. So once you have a model that looks good to go, you're like, hey, this model looks great. I'm ready to deploy it. I'm ready to make some predictions for new applicants coming in. Then you just click on this deploy button, which will bring your model into your flow. Right, and then all we need to do is use one of these score recipes to apply our model on data to predict. So in this case, we're applying our model on this other data set to make some predictions. And here, if we look into the score recipe, we can see that, again, below the run button, it says that this is going to be running in database Snowflake native. And that's because, as I mentioned earlier, Dataiku is able to create a Snowflake UDF from this machine learning model, even if it's something really crazy like this light GBM model, and run the actual compute using your Snowflake warehouse. So again, when I click this run button to apply my model to our new applicants coming in, it'll go ahead and run this query behind the scenes in Snowflake. And indeed, my job succeeded. And now if we look at my data set over here, again, I have each of my loan applicants. And now I have some new columns. So I have the probability that there will be an incident, the probability that the application's okay, and then our ultimate prediction from our model of should we maybe give this person a loan or not. Right, cool. So that's like most of the data science development lifecycle. Everything from bringing data in, joining it together, cleaning it up, doing feature engineering, model training, and model inference. And you can see that Snowflake in this particular workflow is doing all the work in terms of data storage and compute, really at every step of the way. Cool. If you want to deploy a machine learning model for real-time scoring, let's say someone enters in their loan application information into a website and you want to immediately return like a result of yes, you're approved or no, you're not approved. You can easily create an API service just with a couple clicks. Right, and so here I have a nice API service created for you guys. That's all it takes. You just got to point to this model that you created. And then another couple clicks to deploy it, in this case to a Kubernetes cluster, which will serve these predictions in real time. So kind of clicking into this particular model, this again is our loan application model. I have a nice little code example. And here we're just submitting a post to our endpoint URL, and we're passing in the features of like an example loan applicant. So all things that you may like request of your loan applicants. And if I just type this into my terminal, don't you guys love a terminal demo here? We can see that our model immediately returns a result saying this loan looks okay. Even our probabilities of okay, 97% okay, and only a 3% chance of an incident according to our model. Right, so using Dataiku, you can pretty easily deploy models for real-time scoring if you want to do that. And then since our pipelines, we don't want them to be static. We want them to be dynamic. We want them to be living and breathing things that we don't necessarily need to click all these run buttons manually over time. We want automation. So you can go to Dataiku scenarios function and create scenarios, which can, for example, look at our loan data coming in and trigger jobs if our data is ever modified, if there's new loan data coming into our data sets. You can also create time-based triggers. So let's say every day at, 7 a.m. in UTC, I want to do some stuff. You can go and organize that in Dataiku. So in this case, I can choose to, for example, build a downstream data set. So rerun all my data processing pipelines again. I can run data quality checks on this data. As we start to automate things, we really want to make sure that we're not ingesting any bad data in, right? Bad data in equals bad results at. And I can also retrain my model based on this new data coming in. So all of these steps from bringing in data, redoing your feature engineering, retraining your model, performing all these model quality checks on like new data coming into your model, you can automate using Dataiku. All right. Thank you guys for sticking with me throughout that presentation. In terms of what's next, you can explore Dataiku through Snowflake's Partner Connect. And lastly, feel free to contact anyone at Dataiku. Thank you very much for your time.
Almost 10,000 miles away from Africa lies an area known as the Silicon Valley. Known for its Patagonia-wearing inhabitants, indigenous scooters, wild robots, and unaffordable housing. Here, we find a lone python that has traveled all its way in search of colder climates, better opportunity, and stock options. The python can grow to be over 30 feet in length and concatenate string literals together. These non-venomous predators have different diets depending on their size, where most prefer rodents, lizards, and small birds. The one you see here prefers data. Where is this python's journey taking us, you may wonder? Well, to Snowflake, of course. It's in search of their Snowpark to call home after a long voyage across the world. Python for Snowflake has arrived.